Hello and welcome back to the Orange Coast College Mathematics video. In this video, we're going to be talking about solving logarithmic equations. So let's just go ahead and jump right into them. So first off, we have log base 2 of x is equal to 3. Now we can convert this to exponential form by saying 2 to what power is equal to x? Well, it's going to be this number over here. So we can say 2 to the third power has to be equal to x. And so we can write 2 cubed is equal to x, and hence we get to say that x is equal to 8. So number 2 has 3 times log of x plus 15 is equal to 6. Now we can take this 3 and move it to the exponent over here, and so what are we going to get? We get log of x plus 15 cubed is going to be equal to 6. Now from here we might get stuck because I don't see a base. However, if you don't see a base and you just have log, it's going to be our common log, which means that it has a base of 10. So we can say 10 to the 6th power has to be equal to x plus 15 quantity cubed. So this then becomes 10 to the 6th power is equal to x plus 15 quantity cubed. If I take the cube root of both sides, we will get 10 squared is equal to x plus 15. And from here, we can go ahead and simplify. 10 squared is just going to be 100, so we have 100 is equal to x plus 15. If we subtract 15 from both sides, we're going to get our answer of x equals 85. And so let's go ahead and check out number 3. For this one, it'll be nice for us to get all the constants on one side and all the logarithms on one side as well. And so we can add over 1 to both sides. So we'll get natural log of 2x plus 1 is equal to 3. Now the base for a natural logarithm is going to be e. So we can say e to the 3rd power has to be equal to 2x plus 1. So we get e cubed is equal to 2x plus 1. We can start trying to get x alone, and so we can subtract 1 from both sides. So we get e cubed minus 1 is equal to 2 times x, and hence e cubed minus 1 all divided by 2 is going to be equal to x. Now this is our exact answer. However, if we were to plug this into a calculator and round to 4 decimal places, we're going to get that x is approximately equal to 9.5428. Let's move on down to our next problem. Now, this might look a little strange at first, but let's take notice. Both of these are natural log of something. If this is supposed to be equal, well then these two arguments have to actually be the same. And so this really just implies that x is going to be equal to x squared minus 6 in order for the equality to be true. And so what we can do is we can get everything on one side. So we'll have x squared minus x minus 6 is equal to 0. So let's go ahead and factor. We'll get x minus 3 and then x plus 2 is equal to 0. Our zero product property then tells us that x is equal to 3 and x is equal to negative 2. Now we need to be a little careful though before we move on. We need to check each of these and to make sure that they're actually both included in our domain. First off, 3 is going to be inside of our domain. We're not going to have a number that is 0 or less. However, if I try plugging in negative 2, I'm going to be taking the natural log of a negative number. And that is not in our domain. So x equals negative 2 is not actually a solution. And so x equals 3 is our final answer. Let's go ahead and check number 5. Now for number 5, I see that there are multiple logarithms, and it's usually a good idea to condense them into a single log. So let's go ahead and do that. If we add the right logarithm to the left side, we will have log base 3 of 3x plus log base 3 of x plus 2 is equal to positive 2. Now we have the sum of two logs, and so we can combine them. This then becomes log base 3 of 3x times x plus 2, and then this is all equal to 2. From here, we can go ahead and put this into exponential form, and so we'll be able to say that 3 squared has to be equal to 3x times x plus 2. So this becomes 3 squared is equal to 3x times x plus 2. We can go ahead and start simplifying and distributing. So we get 9 is equal to 3x squared plus 6x. We can go ahead and put everything onto one side, and so we are going to get 3x squared plus 6x minus 9 is equal to 0. We can go ahead and factor out a 3, and this becomes 3 times the quantity x squared plus 2x minus 3 is equal to 0. This is then going to factor into 3 times x plus 3 times x minus 1. And so our zero product property is going to say that x is equal to negative 3, and then x is equal to positive 1. However, we're going to have the same issue that we ran into last problem. If I try to plug in x equals negative 3, I'm going to have a domain issue because I'm going to be taking the logarithm of a negative number. So the only solution that I can actually plug in is going to be x equals 1. And that is our final answer. So let's go ahead and move on down to our last problem. So for number 6, first off, on this right side, I see that there's a 3 that can come up and be an exponent. And then on the left, we have two logarithms of the same base, and they're being subtracted. So we can go ahead and combine those into a fraction. This is going to become log base 5 of 5x minus 4 divided by x plus 1. And this will then be equal to log base 5 of 2 to the third power. Now 2 cubed is just going to be equal to 8. Now we notice that we have log base 5 of something is equal to log base 5 of something. In order for this equality to be true, these two arguments have to actually be equal to each other. And so this implies that 5x minus 4 divided by x plus 1 is actually going to be equal to 8. Now we can go ahead and start trying to solve for x. So let's go ahead and multiply both sides by our denominator x plus 1. And we will get 5x minus 4 is equal to 8 times x plus 1. Let's go ahead and distribute. We'll have 5x minus 4 is going to be equal to 8x plus 8. We can subtract the 5x over and subtract the 8 over to get negative 12 is going to be equal to 3 times x, and hence negative 4 is equal to x. Now this is my only possible solution, but as always I need to check if this is going to actually be in my domain. And if I plug it into this logarithm, I'm actually going to be taking the logarithm of a negative number. So this actually isn't even a solution. Since this was our only candidate to be a solution, and we just showed that it's not in our domain, it turns out there's actually no solution for this problem. So we could just say no solution. And why? It's because our domain doesn't allow x equals negative 4. And so we finished our last problem. Well, that's going to do it for this video, and I hope to see you in the next one.